Whoops. Sorry, my camera is having issues. Sorry about that. Should have tried it before joining the stream. Hey everyone. Welcome to Fleet's live office hours. First one for this year. We've been going for about half a year. I think it's been good. I've got some good feedback. I think we'll keep on going. I think this is a good idea to have another avenue for getting information out there about Fleet and having kind of a support pipeline, as well as just ask anything type of forum. And of course, it's also been great for me to get practice being live and making mistakes. All right, so thanks for tuning in. So the high-level purpose of this live office hours is to be answering any technical questions or any other questions about Fleet, deployment, configuration, code base, anything you're curious about. And I won't have all the answers, but I'll try my best to reason through things. I might be slow sometimes and point you to the right direction. So I'll be kind of checking the chat occasionally. And if things are quiet, then we'll just work on kind of the agenda for today. I've been trying lately to kind of have a topic to talk about, so that it's in the title, so people can go and maybe rewatch some of the previous live streams in case they're interested in a specific topic. And occasionally other people drop in from Fleet to help out as well. Okay. So let's get started. Our topic for today is endpoint telemetry. So to give some background, I'm giving a presentation at end of this month, January 31st to be precise, called Endpoint Telemetry Blueprint for Security Teams. And it is the first kind of fleet security type of presentations I'm giving. Zach Wasserman, our co-founder, has given these types of presentations before, but this is the first time I'm doing it. And let me just share the description. Like, I know there's a lot of text. You don't have to read this, but basically, and I'm kind of preparing for this presentation, playing around with some tools. So I guess I've been kind of working on it. It's kind of rough, so I wanted to just pull out some kind of key ideas from it, maybe talk through a few things, and maybe point out things I'm not sure about or I don't know about. So I think best is to get started with what I have so far. So I do have presentations, so I will just skip around. I'm not gonna do the whole presentation, but basically, intro. I'm not really a security person, so I'm still trying to figure things out. Trying to make security simple. I'm kind of giving a rough idea of what I'm going to talk about without going into details. By the way, I do have too many slides right now that I need to cut down. I want to basically kind of present. The idea here is I'm going to present a blueprint for endpoint security that's hopefully straightforward, modular, that's more understandable, something you can look inside of. Right, so kind of taking a step back, when we talk about endpoint telemetry, we're talking about what machines already know about themselves, right? Machines such as laptops, servers, point-of-sale terminals at the store, and many others. And these endpoints generate some of the richest signals we have, processes, files, network connections, startup behavior. And oftentimes these proprietary tools kind of only give you a filtered summary. And so the purpose of Fleet and this telemetry pipeline is to kind of expose this information so it's easily visible. Let's see. Yeah, I like this picture. Okay, so so I want to treat security telemetry here as a system, like the pipeline is a system. So here's a kind of a high-level picture of what the system looks like. Everything starts at the endpoint, right? Your laptop, your server. It's not a layer on their own, but it is kind of the execution surface for everything that follows. From there, we've got the control layer. That's kind of about intent. What questions are we asking endpoints? How do we change those questions safely and consistently? Second layer is ingestion, streaming, and storage. So once data leaves the endpoint, this layer is kind of responsible for moving the data and retaining it reliably. Our third layer is detection and intelligence. That's when we decide like what matters for for whatever you're doing, for security, let's say, or like basically turning this raw data into some sort of signal. And the final layer is correlation and response. That's where kind of humans are more involved in investigation, visualization, and acting on the signals. The rough idea here is like every layer has a responsibility, and so you can swap tools out between layers without breaking kind of the rest of this pipeline. Let me see what else I'm talking about. Yep, this is where I'm saying you can swap things out. All right, let's start with the first layer, OS query. All right, fundamentally how Fleet started was a control layer for OS query, so open source, etc. Should I talk a little bit more about this? Sure, let me just walk through this part a little bit. So OS query, open source, is an open source project that's been around for over a decade, and it's part of the Linux Foundation. So Fleet's Orbit agent is a wrapper around OS query that adds additional tables and some additional capabilities, such as installing software, running scripts, MDM capabilities, etc., etc. But OS query itself is a lightweight agent, runs on laptop servers for macOS, Linux, and Windows platforms. And then high level, it treats endpoints as systems you can ask questions about. So the benefit of OS query is it makes endpoint data accessible without forcing you to write custom programs. You don't have to learn different tools, file formats, or operating system specific commands just to answer some of your basic questions. Instead, information about the system is exposed through a single consistent SQL interface, and I'll have an example later. So OS query uses tables, schemas, and queries, right? Concepts engineers already understand. So if you can write a basic SQL query, you can start asking meaningful questions about endpoints. And the big benefit here is it kind of lowers the barrier for security engineers without having to dumb anything down. So what makes this model work is that all the data kind of shows up in the same shape, right? The same table shape. Data from files, operating system APIs, system services, event sources, it's all normalized into tables, right? You don't need to kind of re-implement parsing logic. You don't need glue scripts here to stitch results together because the data is structured and consistent. You can combine it in SQL. And that's what turns endpoint telemetry from kind of scattered signals into something you can actually reason about. I think I used the term reason about too much in this presentation. All right, and here's actually an example screenshot from Fleet, and it's a real OS query. Zach Wasserman used this example in one of his previous presentations. So at a high level here, this query is asking a simple question. Show me SSH processes that are listening on a non-standard port being not port 22. And what matters here is not the syntax, it's what it represents, right? Process information, network information is normalized so they can be combined easily. OS Core itself has around 300 tables in its core project alone, and they cover things like processes, user startup behavior, files, network connections, packages, hardware, system configuration, etc., etc. And this model is extensible. People create their own tables. They expose application-specific or custom system data. And that makes a foundation you can build on, not a fixed set of signals. I do want to point out, like, I think a common question is like, okay, that's nice, but is there like a library of queries? And the answer is there is a library that Fleet provides, and it's pretty simple. You go fleetdm.com/queries, and you do get simple queries. Let's do Linux. Get authorized SSH keys. Let me see if I click on this. Pretty straightforward. There's an authorized keys table. Okay, let me give an example one. Make this bigger, a little bit bigger. Linux. Let's see. Anything interest? Host entries, network interfaces. Is there anything complex here? Docker contained processes on the system. That's interesting. Let's see. Docker containers joined with Docker container processes. Okay, like, you know, good stuff, good stuff. All right, let's get back to it. All right. Okay, what am I talking about here? Just basically kind of a transition. We're going to talk about. Okay, maybe these couple slides could be cut. Alternative to OS query, scripts, cron, log shippers, OS specific tools. All of these approaches could work. They just kind of shift the complexity, right? The claim here is OS query is a simpler way to do all this stuff, because OS query provides a consistent queryable view of a system state across platforms with one interface. All right, so here's where I go on to the control layer. The control layer is about intent. Once endpoints are observable, next problem is coordination, right? What questions should endpoints answer? When should they answer them? How do we change those questions safely across thousands of machines, right? The control layer turns endpoints into high-fidelity queryable sensors without treating each one as a snowflake. So the control layer in this pipeline, of course, Fleet does more than this, but emphasizing these functionalities, right? Central configuration, query, schedule, settings, define once and apply consistently. Live interaction. During an incident, you can ask questions and get answers. And then consistency, right? The same questions, the same schemas across all operating systems. Of course, we're using Fleet here. It works with standard OS query. Fleet also provides its own open source agent that wraps OS query and provides, like I mentioned, additional capabilities such as lifecycle management, additional tables, running scripts, etc. Example view of the dashboard. There are other tools, but we're not going to mention them here. And there's really not that many other tools if we're talking about open source. As far as we know, Fleet is the only open source control layer that can scale to large numbers of devices. There's nothing else, of course. All right. All right. One important trade-off. So I guess let's jump back and forth since this is live, interactive. So let's see where we are. Our use case is going to be this query. So I have a team here. Blueprint, yep. So I've got this query. Process events. Hold on, how do I view it? Okay, yeah. All right. I'm trying to like show the query. Sorry about that. I don't usually, one query. I want to view it. I click on it. Show query. Okay. Sorry about that. Not intuitive. Not intuitive. Because I thought once I click on it, I would see it. It'd be nice if like I could like see it here. Maybe expand it. Instead, it's like on the right side of the screen, kind of. Anyway, let's look at it. Pretty trivial. I'm basically grabbing all the process events. So this is pretty simple. I'm grabbing all the process events from OS query. I'm grabbing them every 10 seconds and manage animation. Let's see whether I have an animation. And animations are enabled. I do have a webhook configured. And it actually tells me where it's sending the data. So it's sending the data somewhere. Let's not reveal the secret just yet. Where is it sending it? It's sending it to our ingestion layer. OS query data comes to Fleet. Fleet, right as it gets it, it sends it as a webhook in this example. It can also write out it to logs. There's other ways to ship data out of Fleet, but fundamentally Fleet itself doesn't have any buffering. It just, as the data is coming in from OS query, it's just shipping it straight somewhere else. And if that receiver can't accept it, then it sends an error back to OS query. So that means OS query will try to resend that data, right? And if errors keep happening, then OS query will be dropping data on its end, right? So the reason we need ingestion is for reliability, right? We need an ingestion layer that can reliably grab the data that Fleet is sending it, or OS query and Fleet is sending it. I'm just reading my notes here to see if I want to mention anything. Right, so this is ingestion layer is where Buffering, back pressure, and durability are primarily handled. And what we're using in this pipeline is Vector, open source tool. Picks up the data and takes responsibility for moving it downstream. It handles back pressure. It supports structured transforms. So it's grabbing the, we're sending the webhook to Vector, and the Vector kind of it can transform the data into, however you want it for the next part. Don't really have anything to show explicitly. I do have a project where I've been testing this stuff. Part of it has been vibe coded, to be honest. So I don't have anything, any config files or anything to show for Vector. But I do have it running. Alternatives, FluentBit, I think was already mentioned, Logstash, right? So Fleet could dump all the data that it's getting to like a local file, and then these other things can pick it up. But then you have to have like an agent running on your Fleet server, and then if you're scaling, you've got multiple servers. It feels a bit more complicated. It feels simpler for the servers because you can have 10, 30 Fleet servers running. It's a lot easier for them to just send it themselves, as opposed to having another agent running locally that's reading the logs. All right, so after ingestion, we're talking about streaming. Streaming lets you decouple producers from consumers, replay historical data, and rerun analysis as logic evolves. So not every system needs streaming, and this is an optional step. And streaming should come after ingestion, not instead of it. All right, so streaming exists. I feel like it's a duplicate slide here. I'm gonna make a note here. It's good because I need to cut this presentation down a little bit. I've got like 50 slides. It's gonna be 60 slides, and I've got 25 minutes. All right, streaming handled by Apache Kafka. Pretty much, I think it's a widely known tool, right? Provides durable streams that multiple consumers can read independently. So your detection, analytics, experimentation can evolve without changing how data is collected. So streaming, like I mentioned before, it's optional. Not every telemetry pipeline needs streaming. So it makes sense when your detections change frequently. A replay, I think that's a big one. Some people, have to have replay so they can test their alerts, new detection, things like that. You've got multiple consumers, common for bigger organizations. And then you're like experimenting, right? It makes that whole system more flexible. Otherwise, you can drop it, right? And you could hook up ingestion, the Vector tool right next to the next part, which is storage. All right, so I mentioned earlier that don't skip the ingestion layer, right? Don't send data straight to Kafka. Why? Because Kafka can put back pressure onto the control layer, which propagates it back to endpoints OS query, right? And you kind of lose control over buffering, right? The ingestion layer gives you some more buffering. Basically, yeah, like I said, like the comment says, ingestion absorbs a mess. Streaming preserves flexibility. All right, let's talk about storage, right? You ingested data, you streamed it to your consumers. Where do you store it, right? In this blueprint, we're going to use ClickHouse, designed for high volume analytical workloads. It's fast for the kinds of questions security teams ask, such as filtering, aggregating, slicing large amounts of event data. And because it's column-oriented, you can query large data sets efficiently without having to scan everything. And it's open source. It gives you direct access to your data. No proprietary schemas, no hidden query engines. Alternatives. There's lots of alternatives: OpenSearch, Elasticsearch, object storage, Apache Iceberg. Basically, other approaches can work. They optimize for different access patterns. All right, so at this point, we've collected the data, we moved it reliably, and we stored it. So next question is about meaning. How do we turn all this data into signals, security signals that matter? How do we express detections in a way that's understandable, testable, and reusable? So for the split blueprint, we're going to use Sigma. And to be honest, this is kind of an area where that I'm not like too confident in. Sigma is used widely, but it's more of a kind of a tool for larger teams, maybe, right? Like I said, it's a rule format itself. So it lets you describe suspicious behavior in a portable, readable way. So that way your detection logic isn't locked to one backend. However, it requires some glue code, right? We have Sigma used for detection logic, and then we have ClickHouse as the storage. So we need to translate the Sigma rules into ClickHouse SQL. Unfortunately, there's no official backend for doing that translation. That translation for you, although there is a SQLite backend for Sigma that can be used as a starting point. So you can like convert your Sigma rules into SQLite and then modify them for ClickHouse for your alerting mechanism, which I'll mention later. So in practice, as I understand, teams usually kind of build their own tooling here as they grow and mature. So Sigma defines what we're looking for, and SQL defines how we execute it. So let's take a look at the example here. So we have a concrete example here. On the left is a Sigma rule expressing suspicious behavior. Specifically, we're detecting, network tools executed as root, specifically curl and wget. And this is how Sigma, simple Sigma rule looks like. There's a lot more fields that could be added. And then on the right, here's how we translate it into a ClickHouse query. And this ClickHouse query is actually an alerting query, right? It's giving an alert. All right, there's this comment in the chat in Russian. My Russian is not excellent, but I'll try to read this. Interesting. Integrate detection. Yes, I think. I think I've also discussed that it'd be nice for Fleet itself to be a Sigma backend where you can kind of give Fleet Sigma rules, and then Fleet would just kind of translate it into what it needs, OS queries, as well as alerting. Thanks for the comment. All right. What am I trying to say here? Well, basically kind of a summary of basically this is a simple flow, right? In the end, all you need is a SQL query to get your result. Other ways to do detection, raw SQL queries, and then there are stream processing systems like Apache Fink or KSQLDB. There's also SIEM style systems like OpenSearch with built-in analytics. The problem with those, they often hide logic behind abstractions. So each option has trade-offs. The goal here is for this to be kind of an open source pipeline where everything is visible. I think that's what I had for what's what I had for so far. So the next part was going to be the last one, correlation response, for which we're using Grafana. Is an open source project, so I can actually show the example. So we did see this process events. Process events is a webhook that's going to Vector. Vector is sending it to Kafka. Kafka is storing it in Kafka is sending it to ClickHouse. ClickHouse storing it, and then we're using Grafana to query it from ClickHouse. So this is just like a raw stream of data. It's a simple dashboard, right? I currently just have one host in this team, right? Because I only have this single query hooked up to the webhook, so it's only getting sent from here, and it's pretty fast. It's less than a minute before you see. But note, I do have this running really, really often, every 10 seconds. Surely possible, but you probably want to limit this to only like the critical things. By default, you can't even apply 10 seconds. You have to, if you want 10 seconds, you have to use GitOps. If you add a query by default, I think your default is, your minimum is every 5 minutes. In order to get down to 10 seconds, you have to use GitOps. All right, I was going to show. So suppose I have my system here. I'll run this query, this command. So I run this command. So this is kind of what we're trying to detect in our example. And it should show up here pretty quickly. 33. These are round numbers. Let me check the chat. There we go. It showed up, right? And as I mentioned in our example before, we actually created an alert here. We actually create an alert query as well. So we do have our alerts here. Alert rules. We've got an alert for network tool execute as root, and we've got another alert for suspicious cron activity. Let me see. So you can actually see the query here somewhere. it is firing, right? Because I just did it. It's got labels here. So you could configure Grafana to send you alert to like your email or integrated with like Slack or other systems. I wish it had a alert dashboard. Maybe because I'm using like the open source version, it doesn't have an alert dashboard. But in order to see what's going on, I actually have to go down here and show the state history. So by default, the alert fires for 1 minute. That's how it works. I think it's part of the query. We had the interval set to 1 minute. So when something happened, the alerts fires for 1 minute. Okay, so that's all I wanted to cover here about the pipeline, really. I think it's good. It took about 30 minutes. My presentation is 25, so I'm feeling optimistic about being able to deliver this information in 25 minutes. All right, so let's go on to our next thing we wanted to do today, which is work on a few, look at a few things we need to QA in our upcoming 479 release. Let's go look at our boards, which are all public, by the way. This is assigned to me over here. So I did flag a couple of things I wanted to look at. Apologize if this is small print. Let me make it bigger. There we go. There's some things I worked on that someone else will need to QA, but there's a couple things that other people worked on. And the reason we need to help our QA team is because we had this break. Everyone was off, and we want to get this next release out. So effectively, we had less time to QA just because everyone just got back from the break this week. So let's take a look at this one. I did not look into this in detail at all. So let's try to figure out what the issue here. Incorrect state when query report results are clipped. I saved the query that got clipped. Over 1K results. Okay, 1K results. I think that's our default. I think it's talking about this. So when we go to our queries, we can click into this. We can see results. Okay. So this is runs every 10 seconds. So, but we saw results here. So it's talking about this table, I believe. Save the query that got clipped. When I went to the host details page for a host that didn't get a chance to run the query, I saw this empty state. Okay, I'm not exactly sure what the steps are, but maybe. Okay. Expected empty states. There is, okay, the query that creates a lot of rows. Yes. Okay. I'm thinking how to kind of see the issue, because the issue is not obvious to me. So let me think about this. So add a query that creates a lot of rows. After the query report is clipped at 1K rows. All right, let's just do this. Let's see what things I have here. What do I have online here? Online hosts. Another Linux machine. They're on no team. Okay, sure. Let's do query, no team. Hold on. Okay, add query. Select start from processes. It just says create a query. Save. We don't need to run it, right? Query with a lot of results. We save it. And can we run it? Okay. Not enough. We want 1K. Let's run on everything, right? Okay, how does this work? We run a query. So when I did a live query, it did not save the results. In order to use this feature, let's ask. Let's ask unblocked. Trying to use the fleet feature where I see the results of past queries that were run. I click on the query and see. So I guess what I need here is I just need to know what the job. Oh, I need a job. It sounds like I guess what I'm trying to figure out is to understand. I'm trying to understand how this is supposed to work. Fleet is waiting for scheduled query to be reported. Okay, so see, it has to be a scheduled query at a non-zero interval. Okay, that's fine. Let's break it. So we're gonna edit this query. We're gonna make it scheduled. Okay, discard data here, got it. Scheduled every hour, every 5 minutes. Save. Now let's see if we can force the run sooner. Let's go to our database. There's a lot of tables here. Apologize for the small print, but we're looking for the queries table. Queries table, and we're looking for a lot of stuff in here. Order by ID. So we want to order by ID descending. Here we go. Let's see. It's a hack, right? I'm trying to change the interval. Here's the interval, right? Another way to change it, but it's kind of a dev trick. 10 seconds. Let's go. Let's see if we get anything. Automation's off. There we go. Stuff's here. 430. 430, still 430. Come on. Still 430. Why are we stuck at 430? Okay, it's a little slow. 595. Where's our host? Do I need to bring up another machine up? Let's bring up a Mac. I need to log in. It's up. It's up. It should be returning stuff. Let me make sure this is the right server. Nope, nope, not the right server. Let's kill it. Let's do this one. The other one was pointing to a different fleet server that I was testing. It was deployed by our infra team. I was testing some changes. I'm just trying to add more machines here so I have more data. Also, probably doesn't matter by now. I think it's been long enough. Just log in just in case. Okay. All right. So queries, query log results. 8, still not a lot. Did this guy run this? So okay. So I go here. It is, this one is getting all the data. Okay, yeah. It's got the names and all that. Sounds good. Come on, there we go. Report clipped. So the bug says if I go to host that is missing that data, so presumably an offline host, and I click view data. This looks fine. It's supposed to look like this. Report clip. Core has paused reporting and no results were saved from this host. Okay, this is like an old, this is like a story for the whole feature. We're just interested in this one, right? This makes sense. Let me double check the bug. It looks fine. And it's not exactly the same, but it's fine. This query has paused reporting. Complete. results were saved for this host. Looks fine. What else did I want to check? I want to double check the issue. See if there's any comments. Blah, blah. There's a lot of discussions here. Okay, so we are seeing that the cap has been hit. So I think we're good. Keep clicking here because it's got the fleet logo up here. Let me double check just for sanity. Anything I'm missing here? I just spun up this guy. Huh. So the question I have, like, the question I have is, if I go here, how do I know the results have been clipped? How does this feature work? If the results have been clipped, how do I get new results for hosts? I'm gonna have to clear it. I think there's a button somewhere to clear the cache. I'm using this because it's fast. It doesn't feel like it's as fast as it used to be. Advanced option, discard data. So they're probably aware of this, but I'll just make a comment. Like, I feel like as an IT admin, I should go here and I should know that, hey, there's no more results coming in, like, you know. So let me, who's the designer here? Noah's been asking questions, so. It's a little slow because I have this thing enabled. Admin knows that they need to clear the results. They want to see more new data. I'll just put a comment here. So I think we're good. QA done. QA complete. And ready for release. All right, we got 5 minutes. The other one I was looking at was this one. Fleet doesn't escape characters, not supporting an XML. Basically, you can have environmental variables or like fleet secrets that have unsupported characters in XML, which are like these, greater than, less than, ampersand, mainly these 5, right? And if you have an environment variable or a fleet secret with those, your GitOps are going to fail. I think if you have it in your fleet var, it's handled. But if it's an environmental variable or a fleet secret, it's not. So I started looking at this and I noticed that the fix didn't include environmental variables. Okay. Sounds good. Let's look at what he made, the change he made here. We got 4 minutes, so last chance to ask questions. And hopefully they're simple ones. Let's see what he did. Magnus, one of our excellent younger engineers. We check if it's an XML file. This is a helper function. Not a great fan of these. Because I'd rather know like where it's being used first. So I'd rather like see this first and then be like, oh, escape XML. I'd rather be down here, but this is just a language thing. Okay. If not XML, determine XML earlier. Okay, not XML. Otherwise, we escape XML values. Where's this code? This is for each secret. This is not it. This is just secrets. Did I put? Did I click the wrong one? This is no. This is right. Just refactoring. Okay, just moving that logic out to here. And then this is secrets and this is general. Okay, this is just a general case. Okay. Not exactly sure, but let's roll with this. Let's try it. I got 1 minute, so I don't think I'll be able to try it. So I'm gonna do it later. All right, thanks for tuning in. Hope you found this useful. I know I was trying to figure out things, but I feel like my personal opinion, I think it went pretty well. Thank you for your questions, Piotr Ivanov. And have a good rest of the day. Next one's going to be in 2 weeks. I'm thinking maybe I'll talk about, maybe I'll talk about our progress on modularizing the code base. It's more of a technical topic. We'll see what's up. Feel free to suggest topics. All right. Thanks, everyone. See you later.